if I have to find the GCD of two numbers, let's say GCD of A comma B, what do I do? I will try to list out the factors of A, the factors of B, and try to match the highest common factor between A and B. In this way, I will be getting my GCD. Now, this is only possible for smaller values of A and B. Suppose we have a very large number for A and very large number for B. For example, I have the value of A as 45,120 and B equals to 3,000. Let's say 3,000, okay? So, is it possible for me to list out all the factors of 45,120 and 3,000? Yes, it is possible, but it is a very lengthy process, it is very time consuming process, and it is also a very energy consuming process. Okay? To optimize this solution, to optimize this way of finding out the GCD of two numbers, we use the Euclidean algorithm. Okay, now for understanding purposes, I will be using smaller numbers for A and B. Later in the other video, we will try to find out the GCD of two very large numbers. Okay, now for example, I will take the value of A as 64 and the value of B as 14. Okay, we will find the GCD by using the Euclidean algorithm. Okay, now GCD of 64 comma 14. Okay, so now you have to remember something now. Remember the division algorithm? What is it? The dividend is equals to the divisor multiplied by the quotient plus remainder. So this is what the division algorithm. Now we will be using this division algo to find the GCD of two numbers using the Euclidean algorithm. Okay. Now how are we going to implement this in GCD? Okay, we will consider this A as the dividend and we'll consider this B as the divisor. Okay, so over here we have our dividend as 64 and we have our divisor as 14. Okay, so 64 will be equals to, let's divide it, 64 divided by 14, 14 4 times goes 56, remainder 8. Okay, now what is the divisor over here? 14 multiplied by the quotient, which is 4, plus remainder, which is 8. Now we have done our first part of the Euclidean algorithm. Now we have to continue the same process till the time we get this value. We have got over here 8, right? So until we get the value of r as 0, we will continue doing this process. Okay, we will continue doing this process. Now, what will be the new dividend and new divisor? Let's check out that. This divisor, the 14, which we have used as the divisor for 64, that will become our dividend 14, and this 8 will become our divisor. Okay, this will become our dividend. So we'll find the GCD of 14 comma 8. Okay, with the divisor of the previous equation will become the dividend for the next equation, and the remainder of the previous equation will become the divisor of the next equation. Okay, I'll just add a lot of words right now. Okay, so let me optimize it. Now I'll use this 14 as the dividend and this 8 as the divisor right now. So the GCD of 14 comma 8 is an optimized form of GCD of 64 comma 14. It is easier to find the GCD of 14 comma 8 than finding out the GCD of 64 comma 14. This optimization is the Euclidean algorithm. Okay, we'll do this until we get this value as 0. Now we've taken 14 as our dividend and 8 as our divisor. So what will be the answer we will be getting? 8 6 times. One time we've got the remainder as 6. Okay, so this 8 is our divisor right now, multiplied by the quotient, which is 1, plus the remainder 6. Again we have to do another step because we did not get 0 until now. So we will be finding the GCD of 8 comma 6. Again, this divisor will become dividend and this remainder will become our divisor. Okay, so we'll find the GCD of 8 comma 6, which is 8 equals to so when we divide 8 by 6, for 1 times 6 we get this. Okay, I'm doing right. Okay, so I will have the divisor as 6 multiplied by the quotient plus remainder 2. Again we have to do, because we did not get 0 until now, so GCD of 6 comma 2. GCD of 6 comma 2, oh sorry, 6 comma 2 is, the 6 will be the dividend, and 6 when divided by 2, quotient is 3, and we've got the remainder as 0, right? So the divisor 2 into quotient 3 plus remainder 0. Now we've got the GCD of 2 comma 0. Yeah, this divisor becomes the dividend and this becomes the divisor. So we've got 0, right? We don't need to proceed any further out now. We've completed our problem. Okay, now we've got the GCD as 2. Okay, remember one thing, it's a concept that if you have a comma b where b or a, any of the numbers is 0, then the other number will be its GCD. Okay, now therefore at the end the GCD of 64 comma 14 is equivalent to the GCD of 2 comma 0, which is true. This is the Euclidean algorithm. We did not find any factors of 64 and 14, but in a simpler way, in small steps, we've done and we find out the GCD of 2. Okay, it seems that the finding out the factors of 64 and 14 was a very easy process in comparison, but this Euclidean algorithm is basically for very large numbers, as I've told in the beginning, right? So for just understanding purpose, I use the values of a and b very small. Okay, now we're done with this with numbers. Okay, also we'll also do this with in the theory part. Okay, so that you will not find any problem during exams. Okay, now I have to find the GCD of a comma b. What do I say? The a will act as the dividend and the b will act as the divisor. Okay, so a equals to b q plus r. Okay, no, we did not get r as 0, right? So we'll take this q1 and r1. Okay, for easy purposes. Now what did I say? This divisor will become the dividend in the next iteration. B equals to, with a new quotient r1, this r1 will come over here, plus r2, the new remainder. Okay, again the same process, r1 equals to q3 into r2 plus r3. This process will continue until r n minus 1 equals to q n plus 1 into r n plus 0. Now the GCD of a comma b is equals to Rn. This will act as the GCD of our number. Okay, this is the theory part. So this was the Euclidean algorithm. Okay, so I hope you've understood the Euclidean algorithm. I have used the practical way and also the theoretical way. I hope you understand it. Thank you.